Hi all, welcome back to Whoops with C++, session 40. And today we are going to discuss about exception handling, session 4. If you have not watched session 1, 2, 3 of exception handling, please watch it before watching this one. And in today's session, we are going to discuss about a restricted throw, zombie objects, and some of the predefined exceptions provided by C++. Okay, now let's start with the first and interesting topic, restricted throw. Okay, so what do you mean by restricted throw? So the name itself is indicating that we are restricting the throw. Okay, so when do you want? So for example, say you have some function, the library layer guy who has written this function definition, that guy might be throwing some exception. So what you will do is you have to write whenever the caller of that function has to write all the possible exceptions. You have to assume that this person is throwing this exception, maybe from function definition. The library layer guy is throwing integer exception or character exception or constant character star or some other user defined exception he is throwing. So whatever exception he is throwing, you have to think you have to think and provide all the possible exceptions wherever you are calling that function, right? So now what we can do is you have a facility to restrict the exception. So you can say from this function we are going to throw only integer, or we are going to throw only character, or we may throw integer or character. Okay, like that you can restrict the function. But if the function definition is throwing other than the defined data types exception, then it leads to abnormal termination. So like that you can give the restriction to the function definition to throw only a specified exceptions. So what it is saying, we can restrict or control the type of exceptions that a function can throw outside of itself. So from the function definition to outside what you are throwing. See, inside whatever you want you can throw. So for example, inside the function definition you have one try block and another catch block. Okay, from inside the function whatever you want you can throw. But when the exception is thrown from function definition to outside, means to the caller, so then you have with this restricted throw, if you are restricted any exception, then only that particular exceptions can be thrown. If you are throwing other than that, then abnormal termination will takes place. So we can also prevent a function from throwing any exception. What you can do is you can restrict to throw only integer or character or maybe some defined list of exceptions, or you can completely restrict the function to throw any type of exception, like this is not at all going to throw any exception. Okay, so we can also prevent a function from throwing any exception, right? So this is restricted throw. Now how to write the syntax? Say for example, for the first statement, so I want to throw only integer or character. So during that time what you can do, general function definition, function syntax is return type, function name, arguments. So after this what you can do is you can write throw. Within these braces you can write what are the type of the exceptions your function can throw. You can provide it is integer, comma, character, comma, float, comma, constant character star. What are all permissions you want to give to this function to throw an exception to outside. So that list you can provide here. Okay, so the function can throw only type underscore list mentioned. Whatever types you have mentioned, only that you can throw. So but uh, if you don't want to throw any of the exception from the function, the definition what you can do, you can write throw, give the empty list. Okay, so then now restrict the function not to throw any exception. If you are trying to throw any exception from this function definition to outside, then abnormal termination will take place. Okay, now let's discuss one program. Sorry. Yeah, now observe this one. I have taken the same denominator, so division function, numerator, denominator. But here what I'm doing is, so I'm giving the restriction. Now my function can throw only constant character star. If I am throwing other than this, it will leads to abnormal termination. So, but what I'm doing here I'm checking if denominator equals to 0. I'm throwing any integer integer exception. So here you can see I have an integer catch block, right? So here I am calling the function division in comma d. So means I am calling the function division, but this will throw an exception, right? So that is the reason I have called this function division inside the try block. But this function is throwing 0, that is integer, to outside to the caller. So the caller is the main function. To the main function it is throwing 0, right? So now even though you have an integer catch block, this catch block or generic catch block won't execute. It will leads to abnormal termination because you have specified that this function will throw only constant character star, but you are throwing integer. Okay, so now let's compile and see. Yeah, so now I'm compiling with 98 standard, C++ 98. Okay, it's working fine. Edit out. So I will give 10, 0. You can see terminate called after throwing an instance of integer. Okay, so now what I will do is I will, instead of constant character star, along with constant character star, what I will do is I will provide integer also. So now my function can throw constant character star or integer. Now what will happen if I give 10 comma 0? So then this integer catch block will execute, right? Okay, now 10, 0. See, result divisible by 0 is not allowed. Okay, so now one more thing. So why I have given 98 means this restricted throw is working in 9 C++ 98 standard. Okay. Now let's compile it with the C++ 11 standard. Okay. C++ 11. Now you can see the warning. You are getting a warning, right? Dynamic exception specification are deprecated in C++ 11. So in C++ 11, this dynamic giving a restricted throw is deprecated. It will work, but it is saying it is deprecated. It will throw you a warning. Okay. So 10 comma 0. Okay. Divisible by 0 is not allowed. So what I will do is I will delete this a.out file. Okay. And open this once again. Restricted throw. So here what I will do is I will remove integer. So deprecated, but still it will work. It will give the warning, but it will work. Okay. Still I'm getting warning. So compiled successfully. See, terminate call after throwing an instance of int. Okay. So C++ 98 standard, this restricted throw is working. Now in C++ 11 standard, it is deprecated. Now let's compile this program with C++ 17 standard. So C++ 17, it is error. Okay, it is completely removed. So you cannot restrict the function to throw only a specific this one. So this throw is not allowed. It is completely removed. Okay, it will be error. So in this case, if you are trying to move if you are trying to move the code from older version to newer version, like a C++ 98 standard to C++ 11 standard, you have to rewrite this. Okay, so this is not allowed. You have to remove it. Okay, so if you have something like this, you have to remove it, right? Now, so next thing, so now, so then how to do this one? This is also deprecated. So there is something like, so the important point you have to remember is restricted throw is deprecated in C++11 and removed in C++11, 17. So from 17 onwards, there is no restricted throw. There is no alternate for restricted throw. That is the throw with arguments can, and we can have the alternate for throw. So for this throw, whatever is there, right? Throw with argument list, we don't have any replacement for that or any alternate. But throw without arguments, for this we have an replacement in C++17, that is no except. Okay, so then how to write this no except? We'll see one program here, restricted throw. Both, where is this restricted throw? Okay, enable the options, enable. See, now this is C++17 standard. So what you can do is you can give no except. Now from the function definition, if you throw any exception, then it will leads to abnormal termination. You are not supposed to throw any exception from the function definition. That is no except. Okay. Now let's compile this, rebuild this. Okay. Still it is building. Okay, now build and run this program. So what I will do is I am going to give 10 comma 0. So now you can see division terminate called after throwing an instant of character constant star. So this is invalid. See, even though we have generic catch block here, it won't catch it because you have given no except. No except means no exception is allowed. So this is C++17 standard. Okay. So that's about restricted throw. Okay. So again, I am repeating. So restricted throw is deprecated in C++11 and removed in C++17. And there is no alternate for restricted throw. That is the throw with arguments, and we can have the alternate for throw. Throw with arguments, we don't have any alternate. Throw without arguments, we have alternate, that is no except. So if you are moving your old version code C++98 code to C++17 or C++20, so then what you have to do is wherever you have this throw with argument list, that you have to completely remove it, and wherever you have used throw without arguments, that you have to replace with no except. Okay, so that exercise you have to do. Okay, so now next comes another interesting topic, that is zombie object. What do you mean by zombie? Zombie, so it is dead, but it is not completely dead. Zombie means it's like a devil, right? So it is physical existence is not there for that object. Okay, so it's like it is after death, but it is not it is like after death, but it is not reached to heaven. So it is in between, like something like soul, right? That is zombie. So then, what do you mean by zombie object? So what do you mean by object? So or how object will be created? So object creation will take place in two different stages. So one is allocating memory for the object, like how much memory is required for the object, then initializing that object's memory. Once these two steps are completed, then only we can say that object creation is successful. So, say for example, only memory allocation is done and initialization step is not done, then we can say it is object is not created, right? It is just created. It is given birth and then immediately it is died. Okay, so like this is called object sorry, So in these two steps, object creation will be successful, right? One is memory allocation and initializing the object's memory location. Okay. Now, so what will happen for the initialization? To initialize object's memory, constructor is called. Once constructor is executed successfully, then only we can say object is created successfully, right? Now, let's observe one program. Okay, there is something, disable this, and we have the zombie object. Yeah, this one zombie object, why I have brought it is somebody asked in interviews, so that I thought of keeping this one. Okay, so now see, you have a class, my class, and here we have one constructor and destructor, right? So now in the previous session we have discussed that inside the try block, if any exception is thrown, all the local variables, all the local objects which got memory will be removed from the stack frame, and if it is an object, then destructor will be called for that, right? So now what I'm doing is I am creating a local object, my class object. So that when I create the object, so constructor will be called. For first memory will be allocated for this object. So then constructor will be called. So then I'm writing cout constructor called. So after that, what I'm doing is throw exception. Just I'm throwing the exception. So when I throw the exception, the constructor won't execute completely, right? A constructor is not executed successfully. If the constructor is executed successfully, then we will get object creation is successful, right? But here itself I'm throwing the exception. When I'm throwing the exception, object creation is not done successfully, right? So now if the object is created successfully, then only destructor will be called for this. But object is created, memory allocation is done, little bit initialization is done. After that, some abnormal termination happened for this, or some suicide happened. Then what will happen? This object will be in the zombie state. So such type of objects are called zombie object. So you can see first main starts. So inside the try block, as soon as you can create the object, then constructor will be called. So from constructor, I'm throwing the exception. So constructor is not called completely. So then destructor won't be called for this. Then directly exception will be executed. Then main ends. Right. Now let's see. Let's run this program. Compile it first. Okay. Build and run. You can see this, right? So first main starts. After that, I'm creating the object. For this object, memory allocation is done. After that, constructor is called. Then I'm throwing the exception. That exception is of type constant character star. So then constant character star, this one will execute. Then main ends. So there is no destructor call, right? So the object is created, but it is not completely created. So it is in zombie state. If the object is completely created, then only we can say object creation is done successfully. Okay. Yeah. So that's is zombie object. It is I have given it because somebody asked in interview this one, what is zombie object? Okay. So this is the thing. Yeah. And yeah, so zombie objects will get created when an exception is thrown from constructor. For such type of objects, destructor won't be called. So avoid throwing exceptions from constructor. Somebody may ask you like, uh, what will happen if I throw exception from the constructor, or is it is good practice to throw an exception from constructor? No, don't ever throw any exception from constructor. Okay, because object creation won't be successful in that time. You have to handle that, right? Okay. Now, if you want, you can have try catch blocks inside the constructor, but don't ever throw any exception from the constructor to outside. Okay. So next, after zombie object, there are few predefined exceptions present in C++. So those are something like um, some based on some conditions, those exceptions you can have user-defined exceptions, something like bad underscore alloc, bad underscore cached, bad underscore type ID. So these are the some of the predefined exceptions or standard exceptions which are present in C++. That is bad underscore alloc. Whenever any new operator fails, then new will throw bad underscore alloc exception. So new, when will this new operator will fail? New operator is used to allocate the memory for the pointer in the heap segment. So for example, if in the heap segment there is no sufficient memory, then automatically new will fail. So during that time, what it will do is it will throw bad underscore alloc object. So this we have discussed while discussing new operator, right? So when new fails, it throws an exception called bad underscore alloc. So like that, there is something like a dynamic underscore cached. Whenever dynamic underscore cached fails for reference variables, then bad underscore cached exception will be thrown of type bad underscore cached. So and like that, you have something like a type ID. When bad and type ID operator fails, then it will throws an exception of type bad underscore type ID. So these things we'll see in upcoming sessions like bad underscore cached, how it will throw, bad underscore type ID, how it will throw. Okay. So now let's see bad underscore alloc, how to handle it. Okay. Now what I'm doing is I'm trying to, so what I said is when you don't have sufficient memory, okay, then bad new will fail, right? So, right, yeah. So now here what I'm doing is inside the try block, try started. Here for this pointer, I'm allocating use memory, okay? So if this much memory is not available, then what it will do is it will throw an exception of bad underscore alloc. So I'm collecting that object, and in this for every standard exception class or predefined exception classes, there is a method called what. This what function will actually give you what is the type of the exception. Okay. So now let's compile this program and see. Yeah, you can see try started. Now I'm trying to allocate use memory. So since this memory is not available, then it is throwing an exception that is bad underscore alloc. So that is caught by this obj. And here I'm trying to display obj dot what exactly happened. What will give an exception of std scope bad underscore alloc is thrown, means memory allocation is failed, may new failed. So after that it will display main ends here. So like this you can have the standard exception. But if you see here, we are not using any throw statement, right? Throw we are not using. So like this, what we can do is we can create a some standard exceptions like this. Okay, right. So that's about dynamic underscore cached, that is standard or predefined exceptions. So that's for today. So hope you understood. That's for end of exception handling. So we'll discuss with another topic, interesting topic in next session. Thanks for watching.